Okay, number 4, it says there are two common roots in the following two equations. Determine the values of m and n and all the roots of each of the equation. This looks like it's going to be a tough one. Let's go to the whiteboard. And I'll write this down for you. And again, it's not going to be an easy one. So the first thing I want to write down is, this is, at least for me, it's not going to be easy. I have to write things down. I might not be taking the best approach, but the approach I'm seeing. So it's 4x cubed plus 12x squared plus 11x plus m equals 0. Let me just make sure I understand what they said. There's two common roots. This thing has 3 roots to it. All right. So there are two common roots in the following two equations. Determine m and n and all the roots of the equation. So I got to go through some. First thing I'm going to do is I'm going to divide through by 4, and you get x cubed plus, let's see, 3x squared. Oh, this is going to be nasty. 11 quarters x plus m over 4 equals 0. And I divided both sides by 4. Now, what do I know? I know this thing factors. And by its cubic problem, and they have 2 roots in common. I don't know what they are, by the way, but I'm going to say, x minus a. It has 3 roots by it. It's going to factor into 3 factors at this point. X minus b. And I have no idea what the roots are. And then x minus c. All right? Okay, let's look at the other one. And the other one is going to be, I have to write it down now. It's going to be 4x cubed plus 12x squared. I'm sorry, not I'm writing the wrong one down. I'm writing the same one down twice. Let me move my eraser out. I don't want to do the same one twice. Although it couldn't hurt just to check myself, right? So we get 4x cubed. This is the other equation. Minus 20x squared. Minus 21x. Plus n equals 0. Well, what I'm going to do, I'm going to divide by 4 again. It makes it easier for me to write that factorization of it down. So x cubed minus 5x squared. Again, it's nasty, but it's 21 quarters of an x plus n divided by 4 is equal to 0. And by the way, I notice one shares 2 roots with the other one. So I'm going to say it's the a and the b that they share. So I'm going to say x minus a, x minus b. They share that. They have in common, by the way. But it's not going to be x minus c. It's going to be some other letter. I'm going to say letter d now. So what I need to do is, I guess, multiply this thing out. And that looks like it's a nasty thing to do, but I think I can do it. I think I've seen this before too, right? So it's going to be x cubed plus, let's see, minus a, minus b, minus c, x squared. Let's do the next thing, combinations, right? So a, b, ac, and then bcx, minus abc. All right, I think I got that one. Let's do this guy over here now. What's going to be x cubed plus minus a, minus b, minus c, x squared, and then plus ab, ac. Oh, I'm not c, it's a d. I'm sorry. I put it's a d over here. I'm sorry. I'm daydreaming. Let me go back and get my eraser out. Sorry about that. Daydreamed. And let's write that down. So next one's going to be plus AB. They're the same. Plus, now it's going to be AD. And then it's going to be BD. And then minus ABD. All right, time to think. And thinking through these things, Provided my penmanship is okay. I think I can do it. I'm going to start to equate coefficients now. And to do that, I want to point out what I'm doing over here, equating coefficients. I'm going to highlighter out. So first thing I do is, I want to say that this thing would equal that number. And this thing here equals this number. And this here equals this. That's all I'm doing. Because, x cubed is x cubed, by the way. This thing here would match this thing here. This thing here would match this thing here. And this thing here would match this thing over here. That's all I'm going to write down now. All right? Now, granted, I'm hoping it's going to lead to something simple. But I'm going to say minus 3. Let me look at it. Is A plus B plus C. Let me tell you where it's coming from. I looked at these two. I just put 3 would equal minus A, minus B, minus C, and multiply both sides by minus 1. Let's put the next one down. And I'm going to put the next one down as these two over here. And that would be 5 equals A plus B plus D. Well, I'm looking at these two now, and I'm thinking to myself as, the A and B I could just get them to disappear by subtracting. So 5 minus 3 is 8. And then you get D minus C. All right, so that's something I could do, right? Let's do the next one. The next one is a little more complicated. It's like these combinations of things. It's going to be 11 quarters. I'll write that down for you. Equals, I want to point out what we're doing. We're looking at this and this now. AB, AC, plus BC. And then you look at these two now. And that's going to be minus 21 quarters, right? And that equals AB plus AD plus BD. All right, look what are you going to do there. Well, I still want to look at these two equations over here and wonder what to do about that. I guess I could just get the AB to disappear, right? By subtracting. So 11 quarters minus 21 quarters is 32 quarters, right? And then you get AC. The AB is going to disappear, by the way. Plus BC minus AD minus BD. And 4 and 32 is 8 times. By the way, I'm going to say this might be important to me because it looks pretty simple. What do you have here? 8. I'm going to factor by grouping, by the way. And I'm going to rearrange it. AC and AD. And I'm going to say A. And that's C minus D. Then I'll take this one, and I'll pull out a B. So plus B, and that's going to be C minus D. And what does it give me? 8 equals C minus D and A plus B. Well, I'm seeing something now. I'm seeing this, and I'm seeing this, and there is a relationship between both of those. And it's actually D minus C. It's going to be the same thing as, almost the same thing as C minus C, just opposites. So this will be minus 8, A plus B. So I'm going to say minus 1 equals A plus B. This is another, I'm going to say simple fact. All right, let's take a look. Got to go back, right? There's something I'm missing over here. I haven't used those. I'll get back to them later. I'm trying to see if I can get something here, like one of these letters. And I think I can. And I'm looking at, minus 3 equals A plus B plus C. And A plus B is minus 1, so minus 3 equals, well, that's minus 1, right? So now I know what C is. C is minus 2. That's nice. Now, I could probably do the other one too now, right? So it's 5 equals A plus B is minus 1 plus D. Again, we're using simple equations, by the way. And what's D going to be? D is going to be minus 4. I'm sorry, D is going to be 6. Because minus 1 plus 6 is 5. All right, let's take a look. You know what? I can use these now because I know the roots of the problem. And so what do we mean by that? If we go back to the original things, and let me just see if I can go back over here. And I'm going to be looking at this now. And remember I said this factor is like this. So I could write that down. I'll write it down again for you. So you have x cubed plus, let me go back and make sure I'm doing that right, by the way. 3x squared. Let's see, plus 11 quarters x plus m over 4. We said that this thing factored into x. I got to remember what I said, by the way. Oh, x minus a. I do remember that. X minus b and x minus c. Now, what do I know? I know that this is a root of the problem, and this would equal 0. So c is minus 2. So I think I can figure out m now. I think so. Let's put this down. So c equals minus 2. So let's write this down now. So it's going to be x minus a, x minus b, then it's going to be x plus 2. That equals 0. So what do I know? I know I could just plug it in now. And it's a root. I just plug it in. So you just plug it into this thing over here. And I think I'll be able to figure out m now. So what do you get? You get minus 8 plus, that's going to be 3 times 4 is 12, plus 11 quarters times minus 2. I'll do that later, by the way. Plus m over 4, and this better equal 0, by the way. So what do you get over here? Minus 8 and 12 is going to be 4. Here you get minus 11 halves. Here you get m over 4. I think I'm going to get m pretty quick, by the way. This is 8 halves. That's going to be 3 halves, minus 3 halves, plus m over 4 equals 0. M over 4 equals 3 halves. Multiply both sides by 4, and m would equal 6. So I got another thing. I got m is 6. All right. I guess I could do n like that too, right? Let's go back over that. And I think we were doing the n one over here. Let's write this down. So I know d, right? So I'm going to say, I just did it. So d is going to be 6, right? Well, a little more complicated, but you could plug it in. So 6 cubed minus 5 times 6 squared minus 21 quarters times 6 plus n over 4 would equal 0. And again, I know d's a root of it. And what was d? D was 6. I'm just plugging it in. It's a little bit more complicated, isn't it? So, 6 cubed, that's 36 times 6, right? 18, 19, 21, 216. Minus, 5 times 36, 180. This is going to be minus 21. Let's see, we reduce it by 2, right? So it's going to be a 2 there. 3 times 21 is 63. plus n over 4. Kind of nasty, isn't it? Let's keep moving. 216 minus 180, that's going to be 36, minus 63 halves, plus n over 4 equals 0. Let's see, you get 72 minus 63, 7, 8, 9 halves, plus n over 4 equals 0. And I think I could finish this off by saying n over 4 equals minus 9 over 2, or n would multiply both sides by 4, minus 18. So I get n is minus 18 now. This doesn't seem like it's going to end, doesn't it? Let's see, we've got some of the questions answered, by the way. It says over here, 2 common roots, we just are now dependent on that. Determine m and m, I've done that. I've actually determined that. So we got n and m. All right, we got both of these. All right, what else did they say? They said, oh, all the roots of the equation. So I'm going to go back and I'm going to look at the original problems, by the way. I'll write this down for you. The first equation was 4x cubed plus 12x squared plus 11x plus m. What's m? Oh, it's over here. I'm sorry, 6 equals 0. I know there's a root of this over here. What root do I know? The root of that equation, if you remember, we found that was c. And what was c? C was actually minus 2. Yep, c is minus 2. Let's put the other equation down. That's 4x cubed minus 20x squared minus 21x. And what was n? Oh, minus 18. And that equals 0. And I know a root of this one too, and that was d. What was d equal to? Let's go back to that. I found d right. Oh, d was 6. So to get the other roots, I mean, there's a couple different ways of doing it. Bottom line is, I'm going to do it by, I guess a long division would be in order. And it might be the easiest way to do it by long division, because we get a quadratic in both cases, by the way. So let's take a look at it. You get 4x cubed. I'm going to divide it by x plus 2. This is a good way to check anyway. It's going to be 4x cubed plus 12x squared plus 11x plus 6. Well, I'm going to say 4x squared. That's going to give 4x cubed plus 8x squared. You're going to subtract. That will give you 4x squared. Drop the places down. 11x plus 6. What times x would give you 4x squared would be 4x. That gives you 4x squared. And then you get 8x. Lo and behold, you get 3x plus 6. I can say plus 3. What do you get there? 3x plus 6. As expected, by the way. We're getting a remainder of 0. So this first guy here, I'll write this down now. It's the same thing as saying 4x squared plus 4x plus 3 times x plus 2. I'm going to do the other guy. And what do I know about this over here? This is going to be, let's see, that's going to be x minus 6. I'm going to do another long division, by the way. X minus 6. And you get 4x cubed minus 20x squared minus 21x minus 18. And again, I'm hoping this is going to go pretty smoothly, by the way. Otherwise, I made an error somewhere. So I'm going to say 4x squared. What does that give you? 4x cubed. And then 4x times minus 6 is minus 24. X squared. You're going to subtract. You get 4x squared minus 21x minus 18. What do you get next? Plus 4x. That gives you 4x squared minus 24x. You're going to subtract. You get 3x minus 18. And what do you get there? You get plus 3. And that gives you 3x minus 18. As expected, 0. And what do you get there? 4x squared plus 4x plus 3. By the way, as expected, 4x squared plus 4x plus 3. And that equals 0, right? And again, why do we expect that? They said they're going to have two roots common, both same quadratics. Now what do you have to do? I guess what you have to do is figure out the solutions to that. And it looks kind of, I don't think my fingers can do it, by the way, but I really have to find out when does 4x squared plus 4x plus 3 equals 0. And I just don't see fingers working on it. So what I'm going to do is quadratic formula, and you get x equals, kind of nasty, but let's write this down, twice the a, and that's going to be 8 in the bottom, minus the b, minus 4, plus or minus the b squared, which is 16, minus 4, times the a, which is 4, times the c, which is 3. Complex. Minus 4, plus or minus, still going to be 8. Let's take a look at this over here. Do some side work over here. So it's 16, and then minus 3 times 16, which turns out to be minus 2 times 16, which is minus 2 times 16. I'll write that down. So I'll write down minus 16 times 2. Let's just keep going. We get x equals minus 4 plus or minus. The square root of minus 16 is going to be 4i, and then the root of 2. And this is all over 8. I'm going to reduce that, and you get x equals, I'm going to divide through by 4. You get a 2 here, you get minus 1 plus or minus I root, we're divided by 4, by the way, I root 2. Right, if you want to write it in the proper form, it would be minus 1/2 plus or minus root 2 over 2i. And I think we're done. I was going back and read the question and make sure I answered what they said. And we found, I'm going to read the question again. I got to find the question. There are two common roots. We did that. These are the two common roots, by the way. And we've determined all the roots of the problem, by the way. And we'd also determined m and n. And we're done. We're absolutely done with the problem. That was a long question, though, by the way. And I understand that sometimes with long things you might get lost along the way. And that's fine, by the way. Go back and think about it. Thank you.